You know, when you first start out, the sheer number of programming languages can feel, well, just completely overwhelming, right? You've got Python, Java, C++, JavaScript, the list just goes on and on. But here's the thing. What if I told you the secret to mastering all of them wasn't about memorizing endless rules and syntax? What if it's really about understanding just a handful of core ideas that pop up everywhere? Well, that's exactly what we're going to dive into.
Let's use an analogy. Think about human languages for a second. English, French, Spanish. They all have totally different words, different grammar, right? But they're all used to express the same core human ideas. Things like love, or hunger, or ambition. Well, programming languages are exactly the same. They're just different toolkits for telling a computer the same fundamental things.
So that brings up a really important question. Is learning to code just this endless grind of memorizing the specific rules for one language, and then the next, and then the next? The answer is a huge, emphatic no. There's a much smarter way to go about this.
All right, so let's move past all that surface level stuff, past the syntax, and get right to the core of it all. We're talking about the foundational ideas that power literally every program you've ever used, no matter what language it was written in.
I like to call this framework the universal blueprint. Think of it as a set of core principles that, once you really get them, make learning any new language so much easier. It's a total game changer.
First up, let's talk about the absolute foundation, the building blocks of data. I mean, every single program, whether it's a tiny calculator app or a giant social network, has to deal with information. So how does that actually work under the hood?
Well, it all starts with something called a variable. And honestly, the best way to think about a variable is just as a labeled box. You give the box a name, say age, and then you stick some information inside it, like the number 25. That's it. That's how a program remembers stuff so it can use it later on.
Okay, so let's see what this looks like in the real world. Check out these code snippets. In Python, on the left, it's super simple. Age equals 25. Over in JavaScript, you'll see it uses the word let. And then in C#, it's a bit more specific. It says int to tell the computer it's a whole number. See? The syntax is a little different in each one, but the core idea, it's exactly the same. We're creating a box called age and putting the number 25 in it.
But of course, programs don't just deal with numbers. They handle all sorts of information, and that's where data types come into play. A data type is basically just a label that tells the computer what kind of stuff is inside that variable box. Is it a number? Is it some text? Is it a simple true or false? Knowing the type helps the computer handle the data the right way. It's kind of like organizing your pantry. You put the cans on one shelf and the cereal boxes on another. Let's take a look at another quick example. Say you want to store a price, like $10.50. Each language needs to know that this is a number with a decimal point. You'll notice that C# is very explicit about it, calling it a float. Python and JavaScript, on the other hand, are a bit more chill. They can usually figure it out on their own. But again, the syntax might change. But that universal idea of a number type, it's always there.
So what happens when you have a whole bunch of related items, like a list of high scores or all the things on your shopping list? You definitely don't want to create a separate variable for every single one. That would be a nightmare. That's where data structures come to the rescue. Think of them like a bookshelf, a perfect way to organize a whole collection of similar things all in one place.
And if we look at the code, you'll see different names for pretty much the same idea. Python calls this a list. JavaScript and C#, they call it an array. But don't get hung up on the terminology. The key thing to remember is that every single major language gives you a tool for this, a way to store an ordered group of items. That concept of a structured container is totally universal.
Okay, so we've got a handle on how to store data. Now for the really fun part. How do programs actually do stuff? This is where we get into the logic. How a program makes decisions and repeats actions.
You see, programs don't just run blindly from the first line of code to the last. They have to make choices along the way. We call this control flow, and a great way to think about it is like a traffic light for your code. Based on some condition, like is the temperature over 30 degrees, the program decides which way to go, which path to take next. And here's the classic tool for that, the if-else statement. The logic is super straightforward. If the temperature is over 30, then do this, turn on the fan. Else, if it's not, do that, keep it off. And again, look at the style differences here. Python uses clean and simple indentation. JavaScript and C#, they use these curly braces. The look and feel is different, but the decision-making logic underneath, it is 100% identical.
You know, one of the real superpowers of a computer is that it never ever gets bored. It can do the same thing over and over and over again without complaining. And we harness that power using things called loops. This is the concept that powers your social media feed, right? It's just constantly checking for new posts. A great analogy is a conveyor belt, just performing the exact same task on every single item that comes down the line.
So here's a for loop in action. We've told each of these languages to do the exact same thing. Print the numbers from 0 all the way to 9. Now, the setup, the syntax, looks a little different in each one, but that core concept of automating a repetitive job, that is a fundamental pattern you are going to see absolutely everywhere in programming.
Okay, imagine you have a piece of code that calculates the area of a rectangle, and you need to do that calculation all over your program. You really don't want to copy and paste that logic every single time, right? That's what functions are for. They're basically like reusable recipes for your code. I love the coffee machine analogy for this. You just push one button, and behind the scenes, it performs a whole sequence of complex steps to give you your coffee. Functions do the same thing for your code.
And in these examples, that's exactly what's happening. Each language is defining a function called calculateArea. You give it a width and a height, it does the multiplication, and it hands you back the result. When we package up our logic like this, our code gets so much cleaner, way more organized, and super reusable. And this idea of modularity, it's absolutely crucial for building anything even slightly complex.
All right, we've gone through a lot of the mechanics. Now I want to talk about one last, really big idea that kind of ties everything together. And this one is less about writing code and more about a way of thinking. And that concept is called abstraction. It's basically the art of hiding complexity so you don't have to worry about it. Think about it. You don't need to be a mechanic to drive a car, right? You just press the gas pedal. You don't need to know what the pistons are doing. Well, programming is built on that same idea. We use powerful tools and build on layers and layers of abstraction without needing to understand every little detail of how they work.
So when you put all these concepts together, variables, data types, loops, functions, abstraction, they form what I like to call a Rosetta Stone for programming. Once you truly master these ideas, picking up a new language isn't like starting all over again from zero. It's more like learning a new dialect of a language you already speak fluently.
And there you have it, all laid out, the universal blueprint. Storing information, organizing that information, making decisions, repeating tasks, and creating reusable little blocks of logic. This is the foundation. This is what all programming is built on. If you can master these core ideas, believe me, learning the specific syntax of any language becomes the easy part.
So if there's one thing you take away from this, let it be this. Shift your focus. Stop trying to just memorize syntax. Instead, work on really, truly understanding the concepts. Because the best programmers, they always focus on the concepts first and the languages second. So the only question left is, which of these building blocks are you going to tackle first?